Hello, amazing physical science student. It is Mrs. Longton, and I am happy to welcome you to the Module 5 DBA video with me. So, there are 5 questions we're going to do on the DBA, and you'll be very prepared for them if you go over this video. So, there are 5 questions. Number 1, the columns of the periodic table with valence electrons. Number 2, making chemical bonds. Number 3, chemical formulas. Number 4, the tough one, hydrogen bonds. And number 5, acids versus bases. But you'll get a chance to look at the questions and make some notes, so prepare to pause and take some notes as you go through this video, and we'll go through all 5 of them. So first, of course, make sure that you have a periodic table similar to this in your notes that has how many valence electrons are in each column. You will remember that columns 1 and 2 have exactly that many. Column 1 has 1, column 2 has 2, and then you can ignore the D block. And then starting with column 13, just take a 10 away from the number of the column, and you'll have the number of valence electrons. So 13 has 3, 14 has 4, and so on until 18 has 8. Remember that 8 is the magic number, and that means it's a very stable electron. A very stable atom. It has 8 electrons in its outer level, and they all want to get to that. All of these want to be 8. So, keeping that in mind, after I ask this question, go ahead and pause and write down your answer. Feel free to use any of your resources. Are column 17 elements stable or reactive? Here's column 17 right here with 7 valence electrons. So take a moment to pause and write down your answer. And number 2, what I'm going to ask you is to make a bond for me. So look at the periodic table, specifically the valence electrons. Ignore the D block, ignore these. And I want you to make a bond for me. Which 2 elements would you choose? And what kind of a bond do you think it would be? Why would you choose these 2 elements? Why would these 2 elements bond, do you think? And keep in mind the magic number of 8. 8 is where they want to be. So approach this like a math problem. Which 2 added up would make 8? Go ahead and pause and write down your answer to number 2. So for number 3, here is the formula for sulfuric acid. Sulfuric acid's formula is H2SO4. So how many oxygen atoms are in sulfuric acid? And how many total atoms are in sulfuric acid? Take a moment to pause and count them up and write down your answer. Oxygen atoms and total atoms in sulfuric acid. So now we come to the toughie, which is hydrogen bonds. We're going to go over this in pretty specific detail. What causes one water molecule to bond to another water molecule? Well, the answer is hydrogen bonds, and we're going to go over how they work. And this picture, I always love the name's bond, hydrogen bond. But the picture is also completely correct. It's the oxygen side of this water molecule that's going to bond with this hydrogen side of this water molecule. But why? What attracts them to one another? Let's see. So we have to start by making a water molecule. So we know that the formula for water is H2O or HOH, right? So what do we need to make a water molecule? Well, we need an oxygen atom, the O. We need a hydrogen atom because we have the H. But see that little 2? That means there are 2 hydrogen atoms, so I need 1 more hydrogen atom. So let's go ahead and build that. We have 1 oxygen, a hydrogen, and then another hydrogen. So oxygen on its own has 1, 2, 3, 4, 5, 6 valence electrons. That means it's a column 16 electron. And hydrogen each has 1, so they're going to share them. They want 8, remember? So oxygen with its 6 plus 1 hydrogen plus another hydrogen, that's equal to 8. And they're going to share these. Right? In a covalent bond, electrons are shared, and you can think of that as a as you can remember the co part. Co means sharing. If I'm co-teaching with Miss Edwards, we're sharing our teaching duties. So co means sharing. And you can also think of it this way with another James Bond picture is the name's Bond, ionic bond, taken, not shared. Because James Bond orders his drinks shaken, not stirred, right? So ionic bonds are taken, the electrons are taken, not shared. In a covalent bond, they're shared. So we can break this down even further because there are two types of covalent bonds. There's polar and nonpolar. So we're going to go over nonpolar first. Nonpolar bonds mean that there's no difference in charges between the two or more atoms that are sharing electrons. So if I take like one hydrogen with its one electron and pair it with another hydrogen with its one electron, it'll share them and now it has a full outer level because the first level can hold two electrons. So a hydrogen plus a hydrogen, it's a great bond. Um, but both sides have an equal charge of one proton, right? So electrons don't spend their time on one side more than the other side. So we can say that these are shared equally. In a nonpolar bond, they're shared equally. And by nonpolar, it means that they don't spend their time more on one side than the other, on one pole. And I'll go over that again in a second. But you can also think of hydrogen as nonpolar bonds like this with our two little hydrogens. You can ignore the number here because they would have just one proton. But um, look how happy they are. They're sharing equally. The two electrons don't spend more time over here on one pole. They don't spend more time over here on this pole. They spend all their time sort of shared equally in the middle. They're super happy. The electrons don't gravitate towards one pole, one side. They spend equal time with both atoms. Whereas in a polar bond, one atom is more electronegative, which means that it has the ability to attract electrons. So it holds the shared electrons closer to it. And here's a picture. It's a great example of a polar covalent bond. They are sharing those electrons, but chlorine, looking like an old-timey like Western villain, is holding the shared electrons closer to it. And hydrogen looks sad because its electrons that it gave this electron to share, chlorine gets to keep the electrons more than hydrogen. Why? Well, it's because here's chlorine down here. Chlorine is on the right side of the periodic table. Um, and you'll see that increasing electronegativity goes from left to right. So chlorine is pretty darn electronegative, meaning it can attract electrons. Whereas hydrogen's over here, not as electronegative as chlorine on the right side. So hydrogen gave this electron, chlorine gave one of its valence electrons to pair up with hydrogen's electron, but chlorine is really electronegative. It's greedy. It's bigger and it sucks the electrons onto its side farther from hydrogen. And that's what makes a polar bond. So polar bonds have two distinct poles with two different charges. And you can think of that a lot like the planet Earth. The planet Earth has a north pole and a south pole, also magnetic poles, a north magnetic pole and a south magnetic pole. So it has two different charges, two different poles, same as magnets. We call the north and south parts of a magnet their poles. So magnets have two different charges on each side. Like one side has one charge, one side has the opposite charge. And that's the way that it works with a polar covalent bond. You have one atom that has a greater electronegativity than the other atom, and the one with the greater electronegativity attracts electrons. And so those electrons spend more time with this one, than they spend with this one. Now, here's what's the really important part here is that electrons are negative, right? We know that. Electrons are negative. They have negative charges. So what that means is that this guy right here has more negative electrons at any given time than this guy does. And that means that that gives this guy a partial negative charge. The negative electrons spend more time here, giving this guy a partial negative charge. So let's look at that with an H2O atom. We have an oxygen, we have one hydrogen, we have two hydrogens together. So hydrogen has one electron. So this hydrogen gives its one electron. This hydrogen gives its one electron. And then oxygen, because electrons like to pair up, oxygen kind of donates one of its valence electrons to pair up with this hydrogen's electron, and it gives another one to pair up with this hydrogen's electron. But which is more electronegative, oxygen or hydrogen? Well, oxygen is in column 16, so it's on the right side. It's more electronegative than hydrogen. So what happens is that these electrons actually stay closer to oxygen. See them? They're not in the middle. They stay closer to the oxygen side, right? Which gives oxygen a partial negative charge because electrons are negative. So oxygen has more negative electrons hanging around at any given moment, and that gives this side, or instead of side, we can say pole, a partial negative charge. And this side, then, because it doesn't have as many negatives, just has its positive protons, has a partial positive charge. So we use this symbol, which is the Greek lowercase delta. That's an uppercase delta. The lowercase delta looks like this to signify a partial charge. There's not enough going on here to give oxygen a full charge or hydrogen a full positive charge. So we just call it a partial charge. And you can look at it this way too, with the lowercase delta. So this has a partial negative charge on the oxygen side, and the hydrogen side has a partial positive charge. So that's kind of what this looks like. Oxygen's partially negative, and each hydrogen is partially positive. Why? Because the negative electrons spend more time with oxygen, making it slightly negative. What happens if another water molecule wanders on by? Well, it's just like magnets. This positive side, this positive hydrogen side, is attracted to the negative side of the second water molecule. And so they're going to form a bond because opposites attract, just like with magnets. So then a third water molecule moseys on by. And this hydrogen, positive, partially positive, is attracted to this oxygen, partially negative. And if a fourth one comes by or more, the bonds continue positive to negative, positive to negative, positive to negative. And this keeps going. I could have added a row up here and it would have been just the same. There would have been even more. The positives attract to the negatives and start to build these little walls. And what do we call these? Those are hydrogen bonds. So hydrogen bonds form because water molecules, one oxygen and two hydrogen, are polar bonds. The electrons spend more time on one side, giving it a slightly negative charge, and giving the other side a partially positive charge, and opposites attract and form hydrogen bonds. So what I want you to do is to take a moment to pause the video and write down the answers to these four parts of question 4. You can also go back and watch this as many times as you would like to have it down, but what I want you to be able to describe to me is, first, what are the atoms in a water molecule, H2O? Second, is H2O a polar or a nonpolar bond, and why? Third, what are the charges of each of the poles in a water molecule? So what side has what kind of charge? And fourth, what causes one H2O molecule to bond to another? What attracts one H2O molecule to another to form a hydrogen bond? So take a moment to pause the video, make sure you're right, go over it if you need to. And number 5, I'm going to ask you a little riddle. I'm going to hand you a substance. I tell you and I'm not lying, that it's totally safe to touch that substance or even put it in your mouth and taste it. So I'd like you to tell me, what are 3 different ways you can test the substance to determine if it's an acid or a base? Remembering that you can touch it and put it in your mouth, or you can use sort of common laboratory tests. Just make sure that you can tell me what your results mean. So if you say, well, I would test its pH with a test strip, make sure you can explain to me if the pH is X, then that means it's either acid or base. And that's all of it. So at this point, once you have everything down, you can call me or schedule a call. The best way to schedule a call with me is to text me. If you email me, that's fine too. Just give me lots of time. What happens is I only check my email a couple times a day. So if you email me and say, hey, can we do my DBA in 30 minutes? I might miss that or not be able to do it. So you can either just call me and leave a message if I don't answer, and I'll call you back, or you can text me to schedule a call. Make sure that you have your notes from this video with you when we do the DBA, and I hope that you have a great day, and I will talk to you soon.